Hello. I have here a short example of shunt DC generators. So the characteristics of this machine is that it has 4 poles. It has an armature resistance of 0.2 amperes, field resistance of 250 0.2 ohms, field resistance of 250 ohms. Total number of conductors is 120. It's lap wounded. Rated speed is 1000 rpm. The voltage drop at the brushes is 1 volt per brush. So it's supplying two loads. One is 5 kilowatts, the other one is 2.5 kilowatts. So what we're asked to find is the flux per pole and the current per path. For the current per path, I have an illustration of the per path current in my permanent magnet DC example. So you'll find it in another video. Okay, so this is straightforward. So for your generator, shunt generator, this is how it looks like. It's electrical diagram. So I want you to take note of the direction of the current. So since it is a generator, your current goes out of the terminal. So this is my load current. This is where your load is connected at the terminals. So this is my terminal voltage, load current. My field current is going down, positive here, negative here, and the voltage of that is equal to the voltage at the terminal. And then I have my current at the armature that is going out of the armature because this is a generator. So for a total power at the load of 7.5 kilowatts and a voltage at the load, rated voltage of 250 volts, therefore I want a load current of 30 amps. So that's my power requirement. That's my current requirement here. And well, for 250 volts terminal voltage and 250 ohms field resistance, so I have a field current of 1 ampere. Therefore, by KCL, my current at the armature is 31 amps. I have 4 paths on the armature. It's 4 MP multiplicity times number of poles. Well, I was not able to write it here, but this is simplex. I have 4 poles times simplex 1, so that's 4 paths. So 31 divided by 4, my current at the per path is 7.75 amperes. Now, how do you solve for the flux of per pole of this machine? Well, it's related to the armature induced voltage at the armature. So for the induced voltage of the armature, this one, we can perform KVL. So it's basically 250 volts here plus the voltage drop here, which is 31 times 0.2 plus the 2 brushes. Yeah. No. Yeah. So wait lang. Yes, 2 brushes. So that's 2 volts, I think, because we have 1 volt per brush. Where is that? This one. Yeah. So you have 2 volts. Okay. You have 2 volts here. 31 times 0.2, that's the voltage drop at the armature resistance. 250 volts, that's the terminal voltage. So you want 258 volts, 258.2 at the armature, which is equal to 0.0/60A. So we have number of poles for speed, I think that's 1000. Number of conductors, number of parallel paths, so you can isolate flux and solve for that, and that is 0.1291. So that's it. That's shunt. This is shunt generators. So yeah.